physics students. Today we are going to be talking about acceleration and the direction of an acceleration vector. So last video that you all watched, we learned that acceleration is just a description of how fast something is speeding up or slowing down. If we have a bigger acceleration, it's speeding up very quickly, or if we have a small acceleration, it's just getting faster and faster, little bit by little bit. That being said, we also learned that acceleration is a vector quantity, meaning it has both magnitude, so a number, a unit, and it also has direction. So direction very much matters with acceleration, and we're going to talk today about which way an object is accelerating depending on which way it's moving, as well as if it's speeding up or slowing down. All right, so in my first example, we have Mr. Magaluk here, and I am starting from 0, and I'm going to get faster and faster and faster as I cross the screen. Would you say that I sped up or slowed down? Well, if you said speed up, you are absolutely correct. So I am moving in this direction, which for you is to the right. To me, looking at you, it's to the left, but I'm moving to the right, or we'll call this the positive direction. Generally, in physics, anything moving to the right will be positive. Anything moving to the left is negative. Just kind of like a number line that you learned in math. Things to the right are positive, things to the left are negative. Conventional science makes things easier, makes it all easier for us to be on the same page. So, if I'm moving to the right and speeding up, my acceleration is to the right as well. So if I'm moving to the right and I'm speeding up, my acceleration is to the right or in the positive direction as well. Let's say I am moving to the right again. However, in this example, I'm already moving fast and I slow to a stop. Not sure why I had to crouch down there at the end, but I did. In this case, we are moving to the right, but we are slowing down. We're getting slower and slower and slower. Therefore, our acceleration is going to be to the left, or negative. Right now, I just want you to know this. We'll talk a little bit later when we look at graphs and numbers why this is the case, but for right now, I just want you to know that if I'm moving this way and I'm speeding up, my acceleration is also that direction. If I'm moving this way and I'm slowing down, my acceleration is the other way, or to the left. Now, what happens when I'm moving this direction? Well, if I'm moving this way and I speed up all of a sudden, start speeding up, my velocity points in the direction that I'm moving, so it's to the left or in the negative direction. And if I'm speeding up, my acceleration is also in that direction. Okay? Now, what happens if I'm moving to the left or in the negative direction and I'm slowing down? So I'm starting and I'm slowing down to a stop. Well, in this case, our acceleration is the opposite direction, or in the positive direction. So let's just go through and put positives or negatives on each of these. So this is going to be negative and negative. This is to the right, so positive and negative. No, positive and positive. Excuse me, positive and positive. Here we have a positive velocity and a negative acceleration. Positive, negative. And In this case, we have a negative direction of velocity, and we have a positive direction of acceleration. So, if we put a big line right across the middle, these are our examples for speeding up. These are examples of slowing down on the bottom. What do you all notice? And I want you to pause the video and look at this and think about it for a minute. What do you notice about the directions of velocity and acceleration when we're speeding up compared to when we are slowing down? So pause the video here, look at this and think about that. What are the differences between the positive and negative signs up here versus down here? Right, so hopefully you all had some time to think about this. And hopefully you all noticed something that I have noticed as well, which is whenever we're speeding up, whatever direction we're moving in, our acceleration is in the same direction. So whatever way my velocity points, my acceleration points the same way when we're speeding up. And conversely, whenever we're slowing down, my velocity and acceleration are in different directions, or opposite directions, actually completely opposite directions. And that's the key takeaway that I want you to understand. Not the why behind this, but I want you to just conceptually understand that if an object is speeding up, acceleration and velocity are in the same direction. If an object is slowing down, my velocity and acceleration are going to point in opposite directions. And I'm going to write this on the board here because this is a key bit of information that will help you on assignment number 5. Object speeding up. A and V are in the same direction. And for an object slowing down, my acceleration and velocity are going to point in opposite directions. So again, just to reiterate, the key takeaway from this video that I want you to remember is that when an object is speeding up, velocity and acceleration are in the same direction. When an object is slowing down, acceleration and velocity point in opposite directions. So, for example, we have, I'm going to slide this over here. Say we have a car. This is my car. It's a really horrible car. There's some wheels. And it is moving this way. And I said this car is moving to the north with a velocity of 5 meters per second. And then later on, as it goes along, this car is still moving to the north, but now we are moving at 10 meters per second north. Would you say this object or this car is speeding up or slowing down? Well, our number is getting bigger, so we're speeding up in this case. And so, if I were to ask you what direction is the acceleration in this case and the velocity, you'd be able to say the velocity is north because it is traveling north. And whatever direction the object is moving, that is the direction of the velocity. And then if you were to answer what direction is the acceleration, well, because my velocity is that direction, and I know the object is speeding up, so my acceleration and velocity are in the same direction. My velocity and acceleration are north. Or north. North. So they're pointing both in the north direction. Now if we did the same example here, and we had this same car moving at 10 meters per second, and then this car all of a sudden sees maybe a ball cross the street. They're in a school zone, and all of a sudden a kid runs across the road, and the car slams on their brakes and comes to a stop. This car is moving north, and the car is now slowing down. And so what direction would my acceleration be? Now, if you thought to yourself, your acceleration should be south, you are absolutely correct. And let's dig into that a little bit. So my velocity here is in north direction. And because we're slowing down, my acceleration and velocity are going to be in opposite directions. So my velocity is in the north direction, and so what's opposite of north? It's south. So my acceleration is going to be in south direction. Hopefully that is helpful, and that this mini lesson here will help you move through assignment 5 without too much difficulty. If you have any questions, please reach out, please ask me. I'm more than happy to go over anything in class with you, or via email, whatever works best. Thanks for watching. Have a wonderful rest of your day.